Welding simulator is one of the most important devices in welding trainings. In this welding simulator, electrical arc welding, sharp case welding, core wire arc welding, and TIG welding can be made within the virtual reality. On the front of the device, we have screens and buttons part contains the followings: on-off button, restart button, energy indicator, USB socket for recording an update, amperage, voltage, weld type, and the polarization screens. You can store the parts you want to weld in this front drawer. Here you can take the part you want to weld and place it in our stand and make the welding. It is necessary to enter the username on the first screen of the device. I enter a name using the touch screen. In the USB recording section, you can import the welding data made by users into USB. You can download the updates that we will provide for you from the update button. Now, after entering the name, I am tapping continue. On our second screen, I select the parts that we want to weld. For example, let's make a T inner corner welding. I select the thickness of the material and the type of the material. I choose carbon steel and 5 mm and tap continue. I select the welding type that I'm going to practice on this screen. I select the electrical arc welding and tap continue. Our electrodes are electrode rutile, basic or cellulosic types. I select the rutile electrode here. I choose 3.2 mm in diameter and then I continue. On this screen, I am going to select our real desk and lever height. Right now, our desk is on the third and our lever height is on the fourth position. That is our material and its rotation. You can see it here. You can position this part in any positioning. You can also take the lever to the desired height and connect the parts as you like. Here is the location of the connection. We make a rotation of the part. You need to introduce it to the simulation from this screen. I just entered this information. I actually have positioned it virtually, such as in real, and I tap continue. Here we select the venue where we will weld. Construction site, maintenance center, and welding workshop can be selected here. I select the construction site and tap continue. I set up the amp on this screen and select it to polarize and I tap continue. I have chosen the direction of the welding from left to right. I indicated that I would use the welding technique straight and right hand and I tap continue. Currently, the system has created the automatic evaluation parameters. Using these parameters, we can start the simulation or we can also click on the manual evaluation parameter entry and edit the optimum parameters created by the system here if you want. We can change values such as work angle, travel angle, arc length, distance, travel rate, amperage. On this screen, our analysis screen shows the welding parameters that we enter at the top. Position on the left side, arc length, distance, Working angle, travel rate, and travel coordinates are displayed instantly. At the same time, these parameters are instantly shown as graphically on our screen here. If a graphic is in between the two white grid lines, it indicates that this parameter is the best. If it goes up, it indicates that this parameter is excessing. If the parameter goes under the grid lines, it shows that the parameter is insufficient. We can change the pass and parts of the piece from here: incomplete penetration, slag inclusion, undercut, porosity, poor bead placement, extreme convexity, excessive concaveness, wrong weld size, excess spatter, and melt or blow through mistakes are illustrated both on the part and in the mistakes section at the bottom. For example, if this mistake is made in the middle of the undercut, shown in green, a green line appears in the middle of the part. By looking at these lines, it can be seen which mistakes were made in which position of the part. Here also, position, arc length distance, working angle, travel rate are scored. Points are given out of 100 and calculated by the system. The section also shows mistake in percentages. Incomplete penetration, for example, it states here the mistake percentage of the part is made. In this way, it shows all the mistakes. We can record it with the save and exit button and can exit. A different user can start the welding with the same parameters by the restart button. In the help section, distance, angle, speed, and grid lines can be turned on. From the screen section here, we can see the virtual reality screen, that is what the user sees. On the above mentioned analysis screen and also in the partial screen, we can view the angle of the welding that we have just determined. We also have an automatic trigger feature in the options. We have green filter feature. And when we tap automatic calibration in our calibration section and place the helmet in the calibration socket and tap continue, calibration is on process. Just do this when you first turn on the device. Now I'm going to switch to the VR screen and make a welding. You'll be able to watch my welding on this screen. Here on the electrode, which is like a speed dial, will help us adjust the speed of the arc welding pliers. The one on the middle that's similar to the water scale will help you keep your work angle and progression in the most optimized way. The line in front of it as an arrow sign is indicated that you need to keep away if you are too close to the part. If you are too far away, an arrow sign will appear that you need to get closer to it. Now I am starting to weld. Let's close the grid line help here. There are some buttons on my right side. Using these buttons, we can remove the shell of the welding so we can clean the welding. We can move the next pass. We can change its electrode and complete the welding. When I tap the clean the welding, I remove the shell of the welding. When we tap to change the electrode is extended. When we tap the clean the welding, the electrode is extended. When we tap the change the electrode, the electrode is extended. When we tap the change the electrode, the electrode is extended. When we tap the clean the welding, the electrode is extended. When we tap the change the electrode, the electrode is extended. When we tap the change the electrode, the electrode is extended. Now we are on the analysis screen in the screens section. First, let's close all the parameters. Let's look at our position. Our position is between the two grid lines, so in the best way. We have already scored 100 points from the position. Our arc distance at the beginning is at the required values, but later it is too much. Our working angle is almost at the desired values. However, at the beginning it is a little excessing, and then it is in between the two white lines. We have a good travel angle. Speed of travel is mostly a little faster. Accordingly, our average score is 66 points. Here we can see the welding area of the part. We can see the mistakes here in lines. For example, porosity mistakes shown in purple occurred in this section. We see our mistakes in percentage here. Now let's make a new welding quickly, and let's pick the gas welding. Here we select the gas type and the gas flow. And we are adjusting the voltage at the wire adding speed. And we select polarization. On the device we also see the welding type and polarization, where we select the amperage and volt values. Now I tap continue. On this page I made my adjustment quickly again. Let's come to the analysis screen from the screen section and examine the parameters. Our position is at the distance in between the contact nozzle and the workpiece. Our working angle, travel angle, speed, the total score the system gives us 86. We have fewer mistakes this time. We have got a good score. Now let's tap save and exit as well and jump to a TIG welding. Again, we can examine the parameters from the analysis screen and see our score here.